Okay, so just finishing that question, we've got to find the equation of this line in Cartesian form. Okay, so in order to do that, the best form to use is the normal equation of the vector. Okay, and so for that we need a normal vector to the plane. Okay, so if you imagine here is the plane. Okay, we've got point A, B and C. Then a normal vector will be here. Here's A, B, C. So in order to find that, we're going to have to find the cross product of AB and AC. Okay, we're going to need to find that cross product. So what is AB? AB is going to be 311 minus 120. And AC is going to be 103 minus 120. Okay. So what are we going to get? We're going to get 4 minus 1, 1 times 2 minus 2, 3. And then we're going to use that horrible formula, which I'm not going to waste time sort of doing it step by step by step. So you can check my work here. I make it that the cross product is going to be minus 1, minus 10, minus 6. And that will be the direction vector of normal to the plane. Okay, of a normal vector to the plane. So we can now write this equation as a normal vector. So x, y, z is any point on the plane R. Okay, times the direction vector, minus 1, minus 10, minus 6, is equal to a point on the plane. So we can pick any of those points, but I'll pick A. Minus 1 to 0. Especially helps if you pick one with a 0 in it. It just makes it easier. Times the normal vector. Okay, so finding a cross product, so I'm going to get minus x minus 10y minus 6z is equal to 1 minus 20. So minus x minus 10y minus 6z equals negative 19. And, I can just make it look nicer, times everything by negative 1. X plus 10y plus 6z equals positive 19. There is the Cartesian equation of this plane that goes through those 3 points. Okay, so if you know 3 points on a plane, you can work out the equation of the plane. Okay. So now a little bit of problem solving. So we first of all got to find parametric equations of a line through A and B. And then find where this line meets the plane with this given Cartesian equation. Okay, so let's just do the first bit. We've got to find the direction vector of the line, which will be 2, 0, minus 3, minus 1, 2, 3. Remember, it will be OB minus OA. So that's going to be 3 minus 2 minus 6. So the line has equation, any point on the line R, x, y, z, is equal to any point on the line, minus 1, 2, 3, plus some amount of the direction vector of the line. Okay, and now we know it in vector form. We can do it in parametric form pretty easily. We can say x is equal to minus 3 lambda. Sorry, let's just delete that so I don't confuse myself. X is equal to minus 1 plus 3 lambda. Y is equal to 2 minus 2 lambda. Z is equal to 3 minus 6 lambda. And so I've answered the first part of this question, which is to express that line in parametric form. So hence, find where the line meets the plane with this equation. So all I'm going to do is substitute in these values into the plane equation. So I'll get, let's use a different colour, minus 1 plus 3 lambda minus 2 lots of y, which is 2 minus 2 lambda, plus 3 lots of z, which is 3 minus 6 lambda, and that has to be equal to 26. So solve for lambda. We'll get minus 1 plus 3 lambda minus 4 plus 4 lambda plus 9 minus 18 lambda equals 26. Collect together lambdas, I will get minus 11 lambda. Collect together numbers, I'll get minus 5 plus 9 is 4. Take it over to the other side is 22. Lambda equals minus 2. Now what I can do is I can sub that lambda back into the parametric form. So x is equal to minus 1 plus 3 times minus 2. Y is equal to 2 minus 2 times minus 2. Z is equal to 3 minus 6 times negative 2. And so the point of intersection is going to be minus 1 minus 6, which is negative 7. 2 minus 2 times minus 2 is plus 4. So 2 plus 4 is 6. Minus 6 times minus 2 is 12. 12 plus 3 is 15. That is the point of intersection between the line and the plane. Okay, so writing things in parametric form can be very, very useful. Okay, who got another question? It's very similar actually. Suppose n is the foot of the normal from a point A to a plane. Find the coordinates of n and hence find the shortest distance from A to the plane. So a little diagram can help. Here's a plane, here's a point A, and we need a point N on the plane such that it's at a right angle to the plane. Okay, it's the foot of the normal. Let's call this point N. So what we need to do, first of all, is find out what the direction vector of AN is. Now, AN is the normal to the plane. Now, you can establish what the normal to the plane is directly by looking at the coefficients of x, y, and z. It's going to be 1, minus 1, 2. Okay, remember that we said that earlier on. Where did I write it? Oh, maybe I've deleted everything. When we were doing the Cartesian version of the plane, these values are the normal vector of the plane. Okay. Now, so we know what direction vector AN needs to be. It needs to be 1, minus 1, 2. So what that means is we can now write an equation in vector form for the line AN. So we can say the line AN must have equation any point on the line, so 2 minus 1, 3, that's point A, it's on the line, plus lambda 1 minus 1, 2. Okay? Now let's express that parametrically. X is equal to 2 plus lambda. Y is equal to minus 1 minus lambda. Z is equal to 3 plus 2 lambda. And again, what we can do now is we can equate these 2 points. So, I can find out what lambda gets me onto this plane. So again, let's change colour. So I'm just going to sub in 2 plus lambda minus, use brackets, minus 1 minus lambda plus 2 lots of 3 plus 2 lambda equals 27. So 2 plus lambda plus 1 plus lambda plus 6 plus 4 lambda equals 27. How many lambdas? That's 6 lambda plus 9 equals 27. 6 lambda equals 18. Lambda equals 3. And now sub back lambda in, we're going to get x equals, 5. X equals y equals negative 4. Z equals 9. Okay? So we know that this position is 5 minus 4, 9. And we know that A is at position 2 minus 1, 3. Okay, so now I'm just going to delete everything else. If I want to know the shortest distance between the point and the plane, I'm simply going to find the magnitude of the vector AN. So AN is going to be equal to ON, 5 minus 4, 9, minus OA, which is 2 minus 1, 3, which 5 minus 2 is 3, minus 3, 6. So let's find the magnitude of these vectors. Square root of 3 squared plus 3 squared plus 6 squared equals the square root of 9 plus 9 plus 36. So what's that? It's equal to the square root of 54. Which is, can we simplify that? It'll be root 9 root 6 is equal to 3 root 6 units. Okay? So I hope all of that makes sense. If there's anything that's not clear, then do not hesitate.